Board, and here we go. All right, here's 1.2. So today is about graphs and lines. Last Thursday, right? Yeah, we did linear equations. So today's about graphs and lines. So graphs in the form of ax plus by equal to c. These are called linear equations in two variables. And ax plus by equal to c is called the standard form of a linear equation. A, B, and C are constants. They are numbers. X and Y are your variables. A solution to a linear equation in two variables is given as the pair of numbers called x, y. The solution set of an equation in two variables is the solution set x, y. And a graph of an equation is the graph of its solution set. So whenever you're graphing a function, you are graphing all the solutions that hold that equation true. Okay, theorem one, graph of a linear equation in two variables. The graph of the form ax plus by equals c is a line. Linear equation, the name's in there, line, linear. The graph is going to be a line. Okay, so first exercise is using x-intercepts to graph a line. So how do you find x-intercepts? Well, x and y-intercepts. To find an x-intercept, well, x-intercepts lie on the x-axis. So if you're ever on the x-axis, all the values of y are 0. So in order to find an x-intercept, you let y equal 0 and you solve for x. So I guess down here, that's your x-axis, again, where all y values are 0. So to solve for an x-intercept, you set y equal to 0, solve for x. To find a y-intercept, well, y-intercepts lie on the y-axis. To find a y-intercept, you let x equal 0, and you solve for y. So let's go ahead and apply that to this graph below. And we're just going to graph it by using x and y-intercepts. So the first exercise is, let's go ahead and find an x-intercept. And again, to find an x-intercept, we let y equal 0. And we're using this equation above, 3x minus 4y equal to 12. So I'll have 3x minus 4 times 0 equal to 12. So all I did there was plug in 0 for y, just as we stated, which gives me 3x equal to 12. All I have to do is divide by 3, and x is going to equal 4. And this is an x-intercept. This represents a point on the graph. Therefore, if I write this in coordinate form, we're going to get 4, 0. 4, 0. So now let's look at the graph. Let's plot 4, 0. So when x is 4 and y is 0, we are going to be right here on our graph. So when x is 4 and y is 0, that gives us the x-intercept there. Okay, now let's go ahead and find the y-intercept. To find a y-intercept, we let x equal 0. So using the same equation, you're going to plug in 0 for x and solve for y. You'll get negative 4y equal to 12. We divide by negative 4, and y equals negative 3. There's my y-intercept. Okay, and of course, we're going to put it as coordinate. So this will become 0, negative 3. Okay, so now we need to find where to plot that. So negative 3 is going to be below on the y-axis. So 0, negative 3 is right there. And this is one way to graph a line. If you're ever going to graph a line, one method is to graph by using the x and y intercepts. So all we have to do now is just connect these 2 points. And that's it. Oops, as straight as you can. And there we go. That's it. That is graphing by using X and Y intercepts. Okay. Any questions on that? All right. Okay. Let's move on. All right. So the next way to graph a line is by using slope. But let's go ahead and learn more about slope before we get into graphing. So if you guys remember slope from whenever you learned it, we all remember slope as the words rise over run. But that's not going to help us if we're actually trying to find the slope between 2 points. So in order to find the slope of a line, if you have 2 points, x1, y1, x2, y2, then if you are ever given 2 points in a line, you can find the slope by the given formula. And here, the one I circle is the most popular. M, which is slope, is equal to y2 minus y1 over x2 minus x1. And this equation will give us a slope between 2 points on any line. So let's go ahead and find the slope on the given coordinates below using that formula that I circled above. Okay. Okay, so one of the most important things to do before we even start plugging in numbers is to label our numbers. Let's label what we have. The first coordinates, let me move that. The first coordinates I'm going to label as x1, y1. The next coordinates I'm going to label as x2, y2. If everything is nice and labeled, then it makes it easier to plug into the formula. So next, I'm going to write the slope formula. M equals y2 minus y1 over x2 minus x1. And since we have labeled everything nice and neat, we now know where to plug these numbers in. So y2 is 4 minus y1, which is negative 2, over x2, which is 3, minus x1, which is negative 3. Okay, and let's go ahead and simplify this. We all know that minus minus turns into what?
Positive.
Yay, plus plus. Good. So this means you'll get 4 plus 2, you'll get 6 over 6. And the slope between these 2 points given happens to be 1. That is the slope. Okay, there you go. Label everything nice and neat. And go ahead and try these next 2 examples out. I'll give you about 2 to 3 minutes to see what you guys get. Watch your signs, watch everything. So label everything, use the formula, and try it out. Okay, there it is, y'all. So the slope between the last two sets of points, the first one you should have got -2, and the last one you got 0. So are there any questions about those ones? Okay, all good then. Let's move on. Okay, next are just the geometric interpretations of slope. If you have a positive slope, then your line will always go from bottom left to top right on a graph. So positive slope always goes bottom left to top right. Negative slope goes top left to bottom right. If you have a horizontal slope, well, let me see. If you have a horizontal line, then your slope is 0. So horizontal lines have a slope of 0. And if you ever come across a horizontal line, the equation is always going to be in the form of y equals some number a. So if I wrote y equaled 5, that would be the graph of a horizontal line. Okay. And then vertical lines go up and down, straight up and down, and vertical lines have an undefined slope, or the slope is not defined. If you ever come across a vertical line, the equation of a vertical line is always x equals some number a, any number you want. So if I said x equaled 10, it would still be the graph of a vertical line. Okay, so that is just interpretation of slope. So now let's go ahead and graph equations by using the slope-intercept form. So this is your second way to graph an equation, by using the slope-intercept form. And we're all probably used to this formula. We've seen it probably dozens of times. The slope-intercept formula is y equals mx plus b, where m is your slope and b is your y-intercept. Okay, so based on that, since we're given the slope-intercept form, all we have to do is label the slope, label the y-intercept, and we will graph our line by using those. So for the first example, we are given y equals -3/2 x plus 1. What is my slope for this equation?
(3/2).
Good. -3/2 at that, right? All right, -3/2. And then what's the second part? What's my y-intercept?
1.
1. Good. My y-intercept is 1. But since it's a point on the graph, I'm going to rewrite it as 0, 1. Okay. So now we have our slope. Now we have our y-intercept. Let's go ahead and graph it. So let's go ahead and find out where the point 0, 1 is. And that's going to be right here. There's my point, my y-intercept 0, 1. And now we're going to use the slope to graph the rest. This is -3/2. Now, if we're graphing by the slope-intercept form, then we are going to use rise over run. And take note of the geometric interpretations we had in the last page. This is a negative slope. This means that it's going to go top left to bottom right. It's going to go top left to bottom right once we graph it correctly. So when I count the slope, I'm going to go down 3 units. So from my y-intercept, I'm going to go down 3. 1, 2, 3. And I'm going to go over 2. 1, 2. And then we need another point. So from the last point I just made, I'm going to do it again. I'm going to go down 3 units. 1, 2, 3, and over 2. All right. So to make a line without using any x-intercepts, you need 3 points. 3 points is enough information for you. But having more points is also great to know as well. So let's go ahead and create a 4th point. And I'm going to start back at my y-intercept. And now I'm going to go up 3. 1, 2, 3. And I'm going to go over 2. 1, 2. There you go. I now have 5 points. Okay. And now I have enough information. I have 4 points. So let's go ahead and graph. So I'll just be as straight as possible on here. And there's my graph. And that is by using the slope intercept form. All right. Any questions on that one? Oops. Okay, let's move on to the next then. Example 2. They give us 8x minus 3y equal to 24. It's not in slope intercept form, but we can put it into slope intercept form to help us graph it. So what we're going to do here is solve for y. That's what we're going to do. So I'm just going to rewrite it here. 8x minus 3y equal to 24. And then when I solve for y, the first thing I'm going to do is subtract 8x over to the right side. This will give me negative 3y equal to 24 minus 8x. Okay, and now the only thing we have left to do to solve for y is divide by negative 3. Everything gets divided by negative 3. And then what we're left with, I'll put that there, separate operations. We get y equals 24 divide negative 3. That's going to be negative 8. And then negative 8 divide negative 3. We know that negative over negative gives me positive. Okay. And now we're on slope intercept form. But if you don't like the look of that, we'll just rewrite it as y equals 8/3 x minus 8. And from this equation, what is my slope?
8/3.
8/3. And what's my y-intercept?
-8.
Good. There we go. Slope is 8/3. Y-intercept is at 0, -8. So let's go ahead and plot it. So let's find -8 on the y-axis. So there's 10, 9, 8. Here's -8. And now my slope is positive. So positive slope will go from top right to bottom left on my graph. That's what positive slope does. So for this point, we're going to go up 8 units, right? Rise over run. We're going to go up 8 units now. So 1, 2, 3, 4, 5, 6, 7, 8. And we're going to go 3 to the right now. 1, 2, 3. There we go. And we need one more point. So let's do it again. Go up 8 units. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 3 to the right. 1, 2, 3. There we go. 3 points. It's official. 3 points make the line. So let's go ahead and connect our points. And there it is. Graphing by the slope intercept form again. Okay. Any questions on that one? It's bringing back any memories for people. You're like, oh yeah, I saw this like in 2nd grade, right? Okay. Let's go to example 3 then. So we just want to graph x equals -3 and the line y equals 2. Well, x equals -3. If you go back to the 2nd page, what is the type of graph for x equals -3? What type of line is it? Vertical or horizontal?
Horizontal.
X equals -3. Is going to be vertical. So remember, if we look back right here, x equals some number a gives me a vertical line. Y equals some number a gives me a horizontal line. So x equals -3 is a vertical line. So all this means is that we're going to start at -3 on the x-axis and just draw a vertical line going straight up and down. That's x equals -3. And then y equals 2. Well, if x equals -3 was vertical, y equals 2 has to be what?
Horizontal.
Horizontal. Okay. Perfect. So find where 2 is on the y-axis. And we go out and to the right, out and to the left. And there you go. That's how you graph vertical and horizontal lines. Okay. Any questions on this page? That is graphing using the slope-intercept form. Okay. All right. Let's keep going then. All right. So now we get into the problems of creating an equation of a line. So in the past examples, they gave us the equation of a line. Now they're going to give us information to create an equation of the line. So the way to do that is by using this equation called the point slope form. And what's great about this equation or formula is the name of this formula is telling you what it needs to create an equation. This formula says, hey, in order to create the equation of a line, I need a point and I need a slope. Can't get easier than that. So this will help us find the equation of a line given a point and given a slope. And this equation is given as y minus y1 equal to m times x minus x1. Okay, so using this formula, let's go ahead and attempt number 4. Write the equation of the line through the indicated point with the indicated slope. Write the final answer in slope-intercept form, y equals mx plus b. Okay, so here they are giving us the clues. They're giving us that the slope is -6 and the point is -4, 1. They're giving us a slope and they're giving us a point, meaning we can use the point slope formula because that's everything we want. So before I begin, I'm going to label my point -4, 1 as x1, y1, just to put labels on everything. So now let's go ahead and use the point slope formula. And I'll just rewrite it. The more you write it out, the more times it gets burned in your brain. Okay. So now we've written the point slope formula out, and let's plug in the numbers that we know. Here I'm going to get y minus y1, which happens to be 1. equal to my slope, which is given right above, -6, times x minus my x1 value of -4. Okay, then clean it up. I get y minus 1. I'm going to go ahead and make this minus minus into plus plus. So we'll have -6 times x plus 4. What we're going to do next is distribute that -6. And you get -6x minus 24. And then add this 1 over. And we get our final answer of y equals -6x minus 23. And when you use the point slope formula, at the very end, when you solve for y, it puts it into your slope intercept form of y equals mx plus b. All right. Any questions on that?
Yes, I'm sorry. How did you get the -24? My fault. I just
So
used that.
you're good. So to get that -24, this -6 on the outside has to distribute to these two terms.
Okay.
So -6 times x gives me -6x.
Okay, thank you so much.
Yeah. And then the -6 times 4 gives me the -24. All right. Everybody good? All right. Okay. So that's how you find the equation of a line given the information. We're going to do it again for number 5, but this time in number 5, it's only giving us 2 points. So this says find the slope of the unique line that passes through the given points and write the equation of the line in slope intercept form. Oh, and then it says write it in standard form as well. Okay. Did the last one say standard form? No. Okay. Perfect. Okay. So we have a work cut out for us, but we do know something, right? So remember, if we're going to use the point slope formula, we need those two ingredients. We need a point and we need a slope. Well, they're only giving us 2 points. And from what we learned today, what can you find between 2 points?
A slope.
A slope. Good. So that's our first job, is we're going to find the slope between these two given points. And before we do so, I'm going to label everything like I always do. You're going to be x1, y1, x2, y2. And let's go ahead and find the slope. So I'll say 1 slope. We get m equals y2 minus y1 over x2 minus x1. And I have 7 minus 3 over -3 minus 2. So I'm going to get 4 over -5. 4 over -5. Okay, perfect. So I think, well, here you can rewrite it as -4/5. So I think it may want this as an answer in my math lab. But since we're also in business math, we can convert this to decimal. What decimal is 4/5?
80 or 0.8.
Good. -0.8. And the reason I'm converting this is going to make our life easier because you guys already hate fractions, right? So let's just make it a decimal number. Okay. So we now have all the ingredients that we need. Okay, we have all the ingredients that we need. So we have a slope and now we have a point. We actually have 2 points. So let's go ahead and go with that. So step 2, let's go ahead and find the equation using the point slope formula. Y minus y1 equal to m times x minus x1. So y minus y1 equal to m times x minus x1. And we're going to get y minus y1, which I labeled already up there. So y minus 3 equal to negative 0.8 times x minus 2, which is my x1. Okay. And then let's go ahead and distribute that negative 0.8. So I'll get y minus 3 equal to negative 0.8x plus, and negative 0.8 times negative 2. Basically, what is 80 cents times 2? You doubled your 80 cents. So how much money do you have?
60.
$1.60. Good. And then we'll add that 3 over. I'll even put decimals there so we can do the addition. And we get y equals negative 0.8x plus $4.60. Okay. Perfect. So there's that. And now it says put it into standard form. Okay. So this is going to be step 3. Standard form. Okay. So remember from the very first page, we have standard form is known as AX plus BY equal to C. Okay. So what we're going to do here is rearrange the equation we got on step 2. So I'm going to rewrite it. Y equals negative 0.8x plus 4.6. And the first thing I'm going to do is add this 0.8x over to the right side. I'll use a different color there. And what we have is 0.8x plus y equal to 4.6. Okay. But I think this isn't going to be good enough for the MyMathLab answer. I don't think it's going to want decimal numbers in there unless it really asks for them. So how can I get rid of these decimal numbers? What number could I multiply both sides to get rid of those decimals? I guess, what was that?
24.
Well, not by 24. 24, it's good. It'll get us out of there. But let's think smaller. Let's think about what place the decimals are in.
Oh, 10.
The tenths, right? So this 8 and this 6 are in the 10th place, which means if you want to get them out of the decimal, you're going to multiply by
10.
10. So let's go ahead and do that. So we're going to say 10 times 0.8x plus y equal to 10 times 4.6. And what we're going to end up with is, well, what is 10 times 0.8?
8.
8x plus 10y equal to, and what is 10 times 4.6?
460.
Smaller. 46. When are we going to multiply by something smaller? That could work. One more thing you can notice is that everything can be divisible by what number?
2.
2. So I'm going to say this one works, but I'm also going to divide everything by 2. And if I divided everything by 2, I'd get 4x plus 5y equal to 23. Just in the hopes of whichever one my math lab will take. We'll see how picky it is. I'm hoping it'll take the green one. If not, it's going to want the purple one. But this is how you go from 2 points to create the equation of a line. So you have to find the slope. Once you find the slope, you can find the equation by using the point slope formula. And once you have the equation, you can find the standard form by moving things over and getting rid of those decimal numbers. So I know on your homework, it's going to say find the slope first, and then it's going to say find the standard form, and then it's going to say find the equation in slope-intercept form. So I think the best way to handle this question is to find the slope first, then find the slope-intercept form, and then put it into standard form. So I say just work a little backwards, and it'll make it a lot easier. So that's what I recommend, because I've helped students with this problem multiple times. So I wish it was asked the other way, but the way it's asked, it says slope, standard form, and then equation, but you're better off going slope, equation, and then standard form. So when you come across this problem 1.2, that's the recommended way you should work it. Okay, but before moving on, any questions on that?
No, sir.
All right. Okay. All right, applications. Hey, look at that, last page. Good stuff. Okay. So now for these applications, we are going to treat them. These are linear applications. So we're treating these applications as linear applications. So example 6, a clothing store sells a shirt that cost them $20 and retails for $33. And then they sell a jacket that cost them $60 and retails for $93. If the markup policy of the store is assumed to be linear, which we've been doing all day, we've been doing linear equations all day, write an equation that expresses retail in terms of cost. So what we have to know from this problem in step A, it's asking us to create a linear equation. And in order to create a linear equation, we need a point and we need a slope. So our job is to figure out what information they're giving us. So if you look at the first sentence again, they're telling us that they are selling a shirt that costs $20 and retails for $33. Well, guess what? That's going to be our first point. So this is going to be all for step A. Let me zoom in more, just a little bit. There we go. Bring it down. Okay. So for A, first thing we're looking at are the points. The first point they give us is 20, 33. What is the next point they give us?
60, 93.
Good. 60 and 93. They're giving us 2 points. And look at this. What can we find between 2 points?
Slope.
Slope. Okay, and this is all the information given from the actual problem. So they give us 2 points. So now the next thing we're going to do is find the slope. M equals y2 minus y1 over x2 minus x1. And here, y2 is 93, y1's 33 over 60 minus 20. I think that gives me 60 over 40. And again, this is business math, so we can just say 60 divide 40, and that will give me 1.5 as my slope. Okay. Well, now, do we have enough components to find the equation?
No.
You sure? Remember, if we're going to use the point slope formula, what are the 2 ingredients we need?
The slope and a single point.
And do we have that?
Yes.
Yes, we have a slope and we have 2 points. All we need to use is 1 point though. And we already have 1 point labeled nicely as x1, y1. So for my equation, we use y minus y1 equal to m times x minus x1. And let's plug in everything we know. Y minus 33 equal to 1.5 times x minus 20. So we're just plugging in all the info. We get y minus 33 equal to, and now you're going to distribute that 1.5. 1.5x minus, and then you're going to have 1.5 times 20. What's that going to give me?
30.
30. Good. And then we'll add 33, add 33, and we get y equals 1.5x plus 3. This is my cost equation in terms of retail, or retail in terms of cost, right? Is that what it said? Write an equation that expresses retail in terms of cost. Okay, good. So this is my retail equation.
And that's point slope form, right?
And that puts it into slope intercept form, always. So we use point slope formula to put the equation in slope intercept form.
Cool.
And it'll always do it for you automatically. Okay. So now that was A. Everybody good with that? It's basically everything we've been doing today, right? Nothing new other than being an application question. Okay. So B, it says, what does a store pay for a suit that retails for $240? So does this mean that, do we plug 240 in for X, or do we plug 240 in for Y?
Y.
Very good. We will plug it in for Y. Because remember, in this whole problem, cost is represented by X and retail is represented by Y. It's stated in the whole problem, right? says cost 20, retails 33. Cost is X, retails Y. So I guess B, I can do somewhere over here. For B, we're going to take 240 and set it equal to the equation 1.5x plus 3. And now all we have to do is solve for x. So move that 3 over, move that 3 over. We get 237 equal to 1.5x. Divide by 1.5, divide by 1.5. And what is 237 divided by 1.5?
158.
Good. $158 equals X. Okay, perfect. And this would be the cost of the suit. So I'll just say cost of suit. Okay. That was example 6. Any questions on that?
No.
Okay. All right. Let's do it. Last one for today. Yeehaw. All right. Example 7. A charter fishing company buys a new boat for $224,000 and assumes that it will have a trade-in value of $115,200 after 16 years. Determine a linear model for the depreciated value V of the boat T years after it was purchased. So once again, we have our work cut out for us. What A is asking is create a linear equation that will represent the depreciation of this boat. So let's go ahead and examine the problem again, and we'll start with A. And looking at the problem, it's already giving us 2 points. Remember that T represents years and Y will represent price. So if you just bought the boat, how many years have passed?
0.
0. 0 years at $224,000. And then he wants to sell the boat. And after how many years?
16.
16 for a price of $115,200. Okay. Well, we know what to do from here because what can we find between 2 points?
A slope.
A slope. You see how repetitive this is. No matter how complicated it looks, we're doing the same exact thing we've done probably 5 times a day already. So let's go ahead and find that slope. M equals, and I'm sure you know the formula by now. So let's go ahead and just plug in those numbers. 115,200 minus 224,000 over 16 minus 0. I get negative 108,800 over 16 which will give me negative 6,800. That's our slope. And then once we have the slope, we can find the equation. And I'll rewrite this formula. Y minus y1 equals m times x minus x1. Actually, in this problem, it's going to be t. We're not really using x, but I already used x above, so I'll just keep it as x, whatever. X minus x1. Just when we get to the final answer that we're looking for, remind me to replace x with t, if I forget to. So y minus 224,000 equal to negative 6,800 times x minus 0. And then y minus 224,000. Go ahead and distribute that negative 6,800. And lucky for us, it's just at negative 6,800x. Because 6,800 times 0 is 0. Okay. And then to finish this off, just add that 224 over. And we're going to get y equals negative 6,800 x plus 224,000. And this will be our solution for A, but we have to put it in terms of actually V and T. So to put it in those terms, I'm going to just rewrite it as V equals negative 6,800 T plus 224,000. And like I said, nothing new here. Everything we've been doing today, given points, find slope, find an equation, nothing new, just a different type of problem. And I'll probably have to move this out of the way of that graph. So let me see. Move you over there. You can take everything, undo, undo, undo. All right, redo that. And then, there we go. Cool. Okay.
So
there's
just
that. Oh, go ahead.
clarify, this is slope intercept form.
Yes. So this is
Okay.
slope intercept form in terms of V and T. Okay. So the next question, B, says, what is the depreciated value of the boat after 10 years? Meaning, all we have to do here is plug 10 in for which variable?
T.
T. That's it. So for B, we want to know what's the value of the boat after 10 years. Plug in 10. All right, so we'll do this here. Let's say B we'll say V equals negative 6,800 times 10 plus 224,000. And go ahead and just calculate all that. Negative 6,800 times 10 plus 224,000. We get that after 10 years, this boat is worth $156,000. I guess that's not bad for a boat. Okay. And then the next question, C, when will the depreciated value fall below 70,000? So this one is reverse from what B says. B said, after 10 years, what is the value? C says, the value is 70, find the amount of years. So this time, you're going to take 70,000 and plug it in for which variable?
V.
V.
V. Good. So do that below. All right, here. It still works. I'll keep that equation there. C, we are now going to have 70,000 equal to negative 6,800 T plus 224,000. And all we have to do now is solve for T. So subtract 224,000. $70,000 minus 224. Don't forget any zeros. I get negative 154,000 equal to negative 6,800 T. And then just divide by negative 6,800. Divide by negative 6,800. And we're going to round up. First off, I get, let me separate the process again. I get 22.6 equal to T. So if we round that up, how many years?
23.
23 years. Okay, perfect. There's A, there's B, there's C, and then the last question, which is also C, which should be D. Graph V, basically graph our function on the domain restriction 0 to 30 and illustrate the answers to part B and C on the graph. Okay, so let's go ahead and learn how to label our graph. We have enough information. So first off, part D is telling us we have to make our x-axis, or in this case, our t-axis, go from 0 to 30. So let's go ahead and look at the x-axis down here. And I'm going to start with 0 being here. And maybe I can go by 5s. Let me see. I can skip and say 5, 10, 15, 20. Am I going to make it? No, but it's fine. I can extend it one more right here. That'll be 30, right? 5, 10, 15, 20, 25, 30. Okay, so this is for that restriction, 0 less than or equal to t, less than or equal to 30. Okay. And then we bought the boat for $224,000. So 224,000 is the max that my y-axis can go to. So we can go by how many thousands do you think is right?
20,
Go by
25.
Go by 25,000s, or maybe even, no, you might, let's see. Because if it went by 25, 50, 75, well, let's see. 25, 50, 75, 100, 125, 150, 175, 200. All right, good. So I'm going to say 25, 50, 75, 100. And what we must understand is that this is in the thousands, right? And then 125, 150, 175, 200, and we'll end at 225. Okay, perfect. Now, we don't have to pick any points because we already got points from all the calculations we've done today. And they're already giving us points as well. So let's go ahead and finish off this graph. And let's say that at 0 years, how much did the boat cost?
224.
224,000. So that point is going right underneath here. Doesn't have to be perfect. Okay. And then another point they gave us was that, what else? After 16 years, how much is the boat going to be?
115, 200.
115, 200. So again, this is just a sketch. Doesn't have to be accurate. So find 16 years, which is probably somewhere around there, and go up to find 115,000. So I'm going to put that right between 100 and 125. So somewhere around there. And then we have another point from question B. After 10 years, how much was the boat worth?
156,000.
Good. 156,000. So I'm going to put that point right above 150,000. And then we have one more point we can illustrate. After, it's from actually problem C. After 23 years, how much was this boat worth?
70,000.
70,000. 23, obviously that'd be 22.5. I'll put 23 around here, and $70,000 right below 75. Okay. That's enough points. So go ahead and connect them and just try to get it as straight as possible, and bam. There we go. And it said illustrate parts B and C. So for B, it was right here. This was the point 10 and 156K. And then for C, right here, this was the point 23 and 70K. And there we go. That finishes that problem. And another way you can help graph this is by using your graphing calculator or by using Desmos. Desmos is pretty awesome. So let me just show you that, because sometimes the graphs on my math lab are pretty hard to determine which one is the correct answer. So using Desmos can be a lot of help for you. So our equation is y equals, I had negative 6,800x and plus 224,000. Okay, So it's going to graph it, but I need to change some restrictions. So if you see this little tool icon on the top right corner, my graph is going to stay between the domain, which they gave us, 0 to 30. And then my y-axis is going to start at 0 and go up to 225,000. Why not? Close that toolbar and look what we have, y'all. Here is our exact graph using those coordinates. So there's that point. The boat was 0 and 224,000. And if I just drag my finger along, we can find all the other values that we just calculated. Look at that. We said at 10, it was 156,000. At about 23, we were at 70,000. So something like that, wherever that's at. 20. That's way past. Oh no, I'm going the wrong way. There we go. There you go. Somewhere around there. 23 years, 70,000 bucks for that boat. Okay, but Desmos helps. You see how I made the restrictions, I made the graph, and that helps you match up to whatever you have to pick in my math lab. All right. I'll upload these notes to that Canvas module. Other than that, we are done for the day. So if you have questions over the homework, over these notes, ask away.